Welcome to the Smoking Loon 212cc project. The first order of business is to figure out how we're going to get this 212cc engine inside the frame of our Nerve Smoking Loon beach cruiser. We start by removing the cranks because we're going to need a wide crank set, and the chain gear is too big. It prevents us from putting the engine down low in the frame. We want the engine down as low as possible so we can lower the center of gravity of our bicycle for better handling and cornering. So we have the cranks out and the stock chain ring out, and now we can get a better idea of how low we might be able to put the engine. But the seat tube is in the way. There's not enough room inside the frame for the engine, so the seat tube has to be removed and located a little further back to make some space for this 212cc Predator engine. So we just cut the seat tube out of the frame, and then we mock up the engine. Normally we mount our engines flat, but in this frame we just don't have a whole lot of space to mount it flat, and it looks like it'll fit better vertically. So we relocate the seat tube so that we can mount our engine vertically. We're using our seat tube motor mount setup, part number 12416, which makes it pretty easy to mount the engine vertically inside the frame on the seat tube. We have these U-mount brackets, and then we have an aluminum motor plate. It makes it real simple. This is our part of our wide crank set. That's the bearing hanger. And then now we're jumping to a mount for the front part of the engine. We have it mounted to the seat tube, but we want to mount the front part of the engine as well to just make it real sturdy inside the frame. This is the part where normally the gas tank would mount to the engine, but we made this clamping device that clamps to the frame and then bolts to those ears on the front of the engine. And now we're moving back to the rear triangle. We have to open up the rear triangle to make room for the mountain bike style rims that we use, which are wider than beach cruiser rims. So we cut off our rear triangle, we kind of mock it up with the mountain bike rim, and then we come up with a way to widen the rear triangle. We notched this tubing, we notched our triangle, and we kind of piece this together so that we end up with a wider rear triangle that allows us to just simply bolt in the mountain bike rim that has a 6-bolt pattern, which is what we mount our sprocket to. And now here we're making some clearance for the sprocket and the chain, because the chain comes really close to the rear triangle in this section here, and so we basically notched out this section and then welded in some filler plate, and then we ground down our welds, cleaned it up, and then eventually we ended up painting that. But that gave us a little more clearance for our chain. You can see there where the sprocket comes around on the triangle, that's the area that we clearance to make some extra room for the chain. And here we have our rear triangle welded back into the frame, and now the triangle is wider, and the mountain bike rim just slides right into the horizontal dropouts. It bolts right in. Real simple setup. So now we have our motor mounted to the seat post, and we're going to mock up a jackshaft system. So we're using some bearing hangers. We made a bracket so that we can use a jackshaft brake, and so this jackshaft's gonna handle our rear brake system and our gear reduction system. Now moving to the front forks, we need some brakes on the front, so we made this bracket and we used a dual piston caliper and set up a motorcycle brake on the front. Now moving to our exhaust, we wanted something that was taking the heat from the exhaust away from the engine, which is why we came up with this funky design that goes up and around and back. It's an experimental thing, and we like to experiment with exhausts and a lot of these parts for the bikes. But obviously this would burn our thigh, so we had to come up with a guard to protect our thigh from getting burnt. We're going to wrap the exhaust with header wrap, but even still we need an additional guard, so we use this round rod. I believe it's 3/8 inch round rod, and we came up with this simple design. You can see it there, complete and ready for some paint or powder coat, and that's going to protect our thigh. And then we use the same idea for basically a clutch cage to protect our ankle from the clutch. Now we're moving on to the gas tank. We have to come up with a gas tank design. We want to fill the void in the frame with our gas tank, and so we came up with this design that's going to bolt right into that void in front of the engine. This is a bracket that's going to wrap around the down tube on the frame, and then the gas tank is going to bolt to that bracket. This is going to be the filler portion of our gas tank. We weld that tube on there for the filler portion, and then we weld the bung to the tube, and then we have a little cap that bolts on to the bung, and we made our brackets to get our tank inside our frame. It's a nice clean setup. Now we're creating a long manifold so that we don't have to use a fuel pump. We're going to position the carburetor down below the gas tank to use a gravity feed. With all these parts made, we finally painted the frame. We try to keep the standard smoking Loon yellow color. We primed up the gas tank and prepped that for paint, and then we moved on to the engine build. For the 212cc spec class, it's pretty straightforward. You can remove the governor, and you can run stiffer valve springs. You can run a billet rod, billet flywheel, and a PZ19 carburetor, and that's it. Pretty basic rules for the 212cc spec class. So we got our engine built pretty quick, pretty straightforward setup. And then once the engine was built, we mounted it to our motor mount. That's our aluminum motor plate that is set up to be mounted onto the seat tube of the frame. It's a pretty convenient motor mount setup. It has the U-bolt brackets, and it's best to bolt the U-bolt brackets to the aluminum motor plate into the frame before you tack the U-bolt brackets onto the seat tube. So ideally, you mount the aluminum motor plate to the engine, and then you put it in the frame, and then you put the U-mount brackets into the frame, and you bolt them to the aluminum motor plate. Once you have that all bolted and set up, and you basically mock it up, make sure everything fits, then you tack the U-mount brackets into the frame, and then this will prevent them from bending or moving so that they no longer line up with the aluminum engine plate. If you have everything bolted together and you tack them in, the alignment will remain consistent, so everything bolts together. Once you have it all tacked in, then you can unbolt the aluminum motor plate and then finish weld the U-mounts. So now we're setting up our clutch cage. We use the same design as our exhaust protection using the round bar. This little clutch cage prevents our ankle from getting into the clutch. The bolt that's retaining the clutch, obviously that's spinning with the output shaft of the engine, and if you get your ankle into that, it'll chew your ankle up. So we made this simple design, and it prevents our ankle from getting into the clutch. You can see here it's a real simple design, and it does the job. Now we're moving on to the jackshaft. The jackshaft's going to retain our input sprocket, so we have a chain going from the clutch to the input sprocket. Then right next to the input sprocket is the output sprocket, and the output sprocket will have a chain going to the rear sprocket. And then on the other side of the jack shaft, we'll have a brake rotor for basically our rear brake. It's a jack shaft brake setup that we commonly use on our motorized bicycles. Since the rear wheel has a sprocket on the left side for the engine and a sprocket on the right side of the wheel for the pedals, there's not a lot of space there for a rear brake. So we put our rear brake up on the jack shaft, and we've had really good success with that. It's a very strong setup and it works really well for us. Now we're moving on to a chain adjuster for this primary chain that goes from the clutch to the input sprocket. We designed a chain adjuster. It's listed on our website. You can purchase this chain adjuster. Here's our jack shaft brake. This is a real convenient setup for us. It works really well. We just set up the rotor on the jack shaft and then create a mount for the caliper. Now we're moving on to the secondary chain. This is the chain that runs from the output sprocket of the jack shaft and down to the rear sprocket. And there's two reasons for running this jack shaft setup. One is for gear reduction. You have to have gear reduction, otherwise the rear sprocket would have to be huge, almost as big as the rear wheel. And the second reason that we run that jack shaft setup is for chain alignment. It really helps with chain alignment. Otherwise you'd have to offset the engine quite a bit to the right side of the frame in order to line up the clutch with the rear sprocket, and that it just doesn't make any sense to do that. So you use a jack shaft, and the jack shaft makes total sense. It gives you gear reduction and it gives you chain alignment. And we're setting up the chain alignment now, setting up the secondary chain now. And we're not using a tensioner or anything like that on the secondary chain because we have horizontal dropouts on the frame of the smoking Loon. So that allows us to pull the axle back in the frame and tighten the chain that way. And then we file down the teeth on the sprocket so that it allows the engagement of the sprocket into the chain to be much smoother. It makes quite a bit of a difference when we do that. We do that on all the sprockets, the input sprocket on the jack shaft and this aluminum sprocket on the rear axle as well. Now we're moving on to the wide crank setup. This is another item you can find on our website. This is part number 12418. And so we're notching the shaft where the lock collars go, right where the set screws make contact with the shaft. We notch that area, and that way the set screws can basically go into the shaft, and that's really going to help prevent any side-to-side movement, especially if while we're out at the track, if we fall and then the pedal, the crank assembly hits the track, we don't want the shaft to shift from one side to the other because it'll either hit the engine or it'll hit the clutch cage or something like that. And so by making that little notch in the shaft, it really helps keep this shaft in position. And so we put the shaft in. The shaft's on our bearings in the bearing hangers, when the bearing hangers are welded to the frame, and then we use the lock collars to basically lock the shaft in position. So once the shaft is in position, then we can put the cranks on. The cranks have set screws. We tighten the set screws onto the shaft, and then the end of the shaft is also threaded, so we put the bolts into the end of the shaft, and that helps those set screws. It basically helps keep it all solid so that the cranks don't want to come off. And then on the drive side for the pedal cranks, in this situation that we have, our engine is so low that we have to use a tiny sprocket. So we don't have any tiny sprockets that use the bicycle chain, so we swapped everything over to number 35 chain. This is basically an engine sprocket. And so we're using an engine sprocket with 35 chain so that we can run pedal power to the rear wheel. So we also had to convert the sprocket on the rear hub to 35 chain, and that, you know, that rear hub's on a freewheel, so that while the engine is rotating the rear wheel, the pedal side can freewheel. But we do have sprockets for bicycle chain. If you have your engine a little further up and you have a little more space, you can run a typical bicycle freewheel on the rear wheel. So either way, if you're using 35 chain or if you're using bicycle chain, we have the hubs and the sprockets, and they move in and out on that shaft so you can get the proper alignment that you need. And it's a real simple, straightforward setup to get the chain lined up to the rear wheel. And then we thread on our pedals. The cranks take a 9/16 thread, so you need 9/16 pedals. And it's a real versatile, simple, wide crank setup. It clears the 212 and the 79cc Predator, so if you're putting those engines into your bicycle frame, you can really benefit from this wide crank setup. This is a chain tensioner for the bicycle chain side, for the bicycle pedal cranks. We have to come up with a tensioner for this side because we use the horizontal dropouts on the bicycle frame to adjust the tension on the drive sprocket, but you need some slack on the bicycle side, on the pedal side, so that once you set the tension on the engine side, then you can use a tensioner and set the tension on the bicycle pedal side. So the most important thing is that you get the tension set up properly on the engine side. You want that set up properly. That's the side that you don't want to have it too loose or too tight. That needs to be set up perfectly so you don't have any issues. And then once you have that side set up, having this tensioner on the pedal crank side, on the bicycle side, it really helps, makes it convenient. You just set the tension real quick using the idler wheel, and in your. Now we're adding our AGK decal to finish off the Smoking Loon 212cc powered beach cruiser race bike. Now we're curious what the bike weighs. A lot went into this bike, so I think it's going to be a little heavier than our typical motorized beach cruiser. Normally they weigh about 85 pounds roughly, give or take a few pounds, but this one came in a bit heavier. Here we can see 91.4 pounds. Pretty heavy for a bicycle, but super light for a small motorcycle, and that's basically what this is. These things can go over 50 miles an hour easily if you gear them that way. We geared ours for the track, and in the 212cc spec class, I think we geared it for, I want to say for about 48 miles per hour. Our long manifold did a good job. It got cold and there's all this condensation, and it cools the air fuel charge going into the engine, which is fantastic. We went to the race. We raced the 212cc spec class. We did really well. Our bike was very respectable as far as the performance, and we had a lot of fun, which is the whole point of a motorized bicycle. So the bike turned out really great. It's really compact. It has a low center of gravity. We really like our custom take, our custom carburetor manifold. Smoking Loon is such a funny, strange name, but we're real happy with the way this bike turned out. It runs really well. The 212 is really strong. Even though we have the restrictions from the 212cc spec class, it's a strong motor. So we hope you guys really like this video. Thank you for watching.